Hello, everybody, and welcome to the Gala webinar series. My name is Isabella Massardo, and I'm content strategist at Gala. Gala is a nonprofit trade association connecting and supporting the global language industry. In September 2020, The Guardian published an article that was written by GPT-3 with text that was input by a computational linguist. One of the Guardian editors proceeded to edit the text as if it had been written by a human. And the conclusion was the editing GPT-3 op-ed was no different to editing a human op-ed. So today we have with us Konstantin Savenkov and Grigory Sapunov, co-founders of Intento. And they're going to tell us about text transformers, stochastic parrots and black swans, and of course, the GPT-3. Before we start the presentation, just few household rules. You are muted to cut down on noise, and if you experience any technical difficulties, you can let me know by using your chat box, and I will help you. We will try to get to as many questions as we have time for at the end of the presentation. So if you have any questions for our presenters, please type them in the QA feature. You can use the chat button on your control panel to chat with other attendees, and you can direct the chat to the panelists or to everybody. We are making a recording of this presentation, and you'll receive a follow-up email. And the recording will also be published on the Gala website at the beginning of next week. So, gentlemen, the floor is yours.
Thanks for the introduction and inviting us. So you see, we adjusted the title a little bit to put some perspective, because, you know, Black Swan is something unexpected event changing lots of things. And stochastic parrot is like ironic description of this type of technology, because some people tend to think that it doesn't really create content, it just that's what parrots do. There were three parts in this presentation. First, I will briefly address how we see place of this technology in the industry, in the content creation chain. Then Grigory will make an overview of the technology itself, of what's different from what we all call machine learning. Then I will go through, then will be funny part, I will just go through some of the practical applications which we have seen across our customers for the last maybe half a year. You'll see how it works in practice. So, as a company, we intend to mostly focus on machine translation, where we help to, build best fit portfolio of models which properly translate certain language pairs and content types. And translation is, you may think of as final step of this content creation, where you already have a content and you want it to be disseminated across different languages. And translation is one of the oldest, I think, cases where humans work, or at least trying to work alongside machines, probably since 50s. So for translation, we have lots of capable models, so many so that it's really hard to choose the best one. We have extensive tool support through CAT tools, TMS, and those tools support these human-in-the-loop workflows. And we see rapidly expanding adoption across enterprise and language service companies. If you look at adjacent technologies as character recognition, speech transcription, speech synthesis, it's very close to translation, just enables translation to work with other types of content. There's also a decent amount of quite good models. However, in terms of the tool chain, it's relatively poor. You have less tools where you can conveniently work alongside machines. And then the most earliest part of this content creation chain, content authoring and improving reviewing content created by humans and rewriting this content in different styles. It's probably the less mature technologically part, which mostly relies on humans with very, very basic tools. There is almost no support for working alongside machines, except things which we just started to experience, those types of predictive output, which you now see in text editors, and predictive keyboards, which you may see on your phones. It's very, very early steps. And today we're speaking about models, about AI part. We will not be talking about tools and how to organize those workflows, because those are things which probably we don't know yet. We're just experimenting with our customers and partners around that. So that's for later. Grigory?
Yeah, here will be a brief introduction into transformers, and I'll talk about what it is and the recent progress that changed the field almost completely, I think. So let's go. The transformer is basically a new type of neural network. They are a very recent invention. They emerged in 2017, and transformers are based on attention mechanisms. You probably heard about other types of neural network, like recurrent neural network, LSTMs, and so on, and they were pretty useful in machine translation and other NLP tasks before transformers. But right now, transformers tend to dominate the field, the different fields of NLP. And that's because comparing to recurrent neural networks, transformers has a much better computational efficiency, and then they can efficiently exploit modern hardware like GPUs and TPUs. And thanks to this, it allows training on much larger data sets, and you can build larger models with better capabilities. We won't dive into the inner workings of the transformers, so if you are interested in how does they work and what's the mathematics behind it, I don't say anything about this, but here's a link to a great visual article by Jay Alamar. Go for it and read it. It's beautiful. It's the simplest explanation of transformers I've ever seen. Transformers tend to be huge models, and they trained on large amount of data. And here's a table from a recent paper on transformers and on language models. And you see here some well-known models you probably heard of, like BERT or GPT-3 or T5 or some other models. And you see that the models tend to be larger every year, and this size is measured in terms of number of parameters that is needed to describe a model. And BERT was like 300 million parameters, and each parameter is usually 4 bytes. So the size of the model in megabytes, actually in gigabytes, is more than 1 gigabyte. And the BERT is the smallest of these models, one of the smallest among the models in this table. And then models get bigger and bigger. And right now the typical numbers are tens and hundreds of actually billions and hundreds of billions of parameters, and even sometimes trillions of parameters. That's really huge models. Then they don't fit into any single computer. And just to run these models, you have to maintain a cluster of machines, of GPU machines, of TPU machines. It's a very expensive thing. and it's hard to just run this model, not even train. And in parallel with the larger size, you see that the data sets that these models are trained on tend to be bigger as well. And typical data set is hundreds of gigabytes, and we'll soon see data sets of terabytes. Actually, all the crawled internet and sometimes filler is here. These models tend to use all the available data on the internet. So it's really huge models and trained almost all available data. So that's a big thing. With all the recurrent neural networks, you can do this. They were just very inefficient for this. Yeah, and I mentioned that these large models are trained on a huge amount of text, and the trick is that these models are pre-trained. What does it mean? They're pre-trained in an unsupervised, or sometimes it is called self-supervised manner. That means that you don't require human labeled data. You just use plain text as is. And here is some example of tasks that these models are trained on. The simplest one and the most intuitive one is a language modeling. It just tries to predict the next word based on some sentences, some context. You just predict the next word, and then you can add this predicted word to the sentence and predict the next one, and so on and so on. So that's a simple way to train a model on just text. Another useful task is masked language model. It's interesting because you take some text, then you mask some tokens in this text by special token or by random tokens. By tokens, I usually mean words, but sometimes it's typically more complicated. It's sub-word units, but it doesn't matter for now. And the goal of the model is to recover the corrupted tokens. And in doing so, the model somehow kind of magically learns something important about the language, the relationship between words and some kind of world model based on this large amount of text. These two tasks are the most popular ones, but they are not the only ones. There are another tasks like multilingual masked language modeling. It is useful for multilingual text. There are translation language modeling tasks. It's useful for multilingual and especially for translation-based models as well. There is next sentence prediction. Right now, it's not very useful as in early days of transformers. Among the recent one is cross-lingual contrast, and there are other types of training tasks. So to give you an intuition what's behind the two most popular training tasks, the language modeling, the simplest one, you just take some text, you split the text into meaningful chunks, and then you produce a training data set. You have a beginning of the sentence, and then you have a next word, just like the target, the label to predict. And you train the model on these types of data. You don't need any human curation for this. You only need to filter the original data set to remove noise, broken text, and it's actually an important step because you need to avoid different biases and filtering affect this stage. But for now, we will not focus on it. You just prepare a data set and the goal of the model to predict the next word. And you train these models on hundreds of gigabytes of such examples. Another important task is masked language modeling. And This task is typically used for BERT-like models, and the previous language modeling task is used for GPT-like family of models. And here's a visualization of how does MLM works. So you have an input, and then you mask some tokens in the input, typically 10 to 20%. And then the goal of the model is to recover the masked tokens. And the model gives you, for each masked token, the model gives a probability distribution among all the possible words, and then just take the most, the word with the highest probability. And in doing this training, the model learns to recover the important words, and all the data to recover the original words is the context, the words around, and the model inside the world model inside the neural network model to have some kind of understanding, in quote, of the general linguistic world. So how to use these pre-trained transformers and how to use transformers in general. You actually have 3 different choices. First of all, you can train any transformer from scratch. You just build your model in any neural network framework. You collect the data set and you train it. Simple to say, hard to implement, because the model is huge. It won't fit into any typical computer. You have to build your cluster. You have to hire a team of data scientists, engineers, a lot of work, a lot of money, a lot of infrastructure. It's almost prohibitive. Some estimates about training the largest version of GPT-3 says that it takes several $1 million just to train. So it's almost impossible for anyone unless you are Microsoft, Google, or OpenAI. Another option is to fine-tune. Sometimes pre-trained models are published, and you can download this model to your computer or to your own cluster, and your data scientist can fine-tune this model to your particular task. What does it mean? That means that you have a much smaller data set for your particular task, say for sentence classification or sentiment analysis or anything else. And you do not train model from scratch. You take this trained model with learned parameters and weights, and you kind of retrain it in an easy way. So you provide the model, the already trained model, with your examples, and try to teach the model on some new tasks. It's easier than training from scratch, but it still requires significant amount of AI expertise, software expertise, and infrastructure. And for largest and there are some other complications, like many models are not published, and you have no such option for GPT-3 for now. You'll soon have, because there is an open source movement to reproduce GPT-3 and publish it, but I think it's not fully ready for now. And even if GPT-3, the largest one, was published, you can't easily take it and fine-tune, because it's very large model, and you still need all the infrastructure for training. It's prohibitive, again, for most companies for using these really large models. And the last case is to use model as is, and it's the most useful case for GPT-3 and the models of similar size that you almost cannot use internally without very large cluster of computers. The point is that the model incorporates a lot of linguistic knowledge, and it knows somehow a lot of things, facts, and relationships among different things, and you can try to communicate with this model. So let's dive deeper into different types of model. Yeah, and there is an important caveat here. Transformers have a limited context size. What does it mean? Transformer consumes some sequence of tokens or sentences, and token is typically something in between character and word. There are two extremes: character-based models, where each symbol is a token, and another extreme is a word-based model, where every word is a token. Character-based models tend to use a larger context. Your sequences are larger, longer, and you cannot easily use very long sequences with a transformer. And word-based models are not good for cases when you have some rare words, and you always have out of vocabulary words. And for working with it, you have to increase your vocabulary and you have to retrain models for it, so it's not feasible. So the real world cases use subword tokens. There are many options for this. It is called BPE or sentence piece or some other things. The point is the most frequent combinations of words, it's typically roots, suffixes, prefixes, and so on. They tend to form tokens or units of vocabulary, and all the words are combined from these units, and every rare words, every new word can be combined from these tokens, so your model can deal with it. That's a good point. And every sentence that goes into transformer are tokenized, and then this sequence of tokens goes to the transformer. And here's a caveat, because transformer have a limit on the number of tokens, and BERT-like models usually have a limit of 512 tokens, and GPT-3 has a limit of 2048 tokens, and that actually significantly limits you in what kinds of data you can use. So how does GPT-3 work? And as you remember, GPT-3 performs language modeling tasks. It predicts the next word. So the model gives you an answer using some text on its input. And this text is comprised of two things: the task description and examples. And you can use no examples, one example, or few examples, and these modes are called zero shot, one shot, or few shot in context learning. Here you don't need to train model, you actually try to convince model to produce result you want. So you invent, you design a prompt, a task description, you design examples that should explain in quote to your model what do you want, and then you hope to get the expected result. It's not trivial. You have to try different ways of explaining the model what you want, and this work is typically called prompt engineering. And given the limited context, it gives you more constraints, so it's really hard and tricky. So if you want to learn more on GPT-3, here's an article I wrote in Medium, so dive into it if you want. So for now, that's it with GPT-3. Let's briefly talk about other models you probably heard of: BERT or Roberta or DiBerta, and some other models are well-known types of models, and they are completely different from GPT family. These models produce high-quality representations for incoming data, and these representations are useful for similarity search, for some NLP tasks, for many NLP tasks actually, like sentence classifications, sentence pair classifications, sentence tagging, and so on and so on. The important thing is that BERT family models are typically not suited for content generation. They are suited for many NLP tasks, and in many cases, they require fine-tuning. And you probably heard of DeBerta. DeBerta is the latest BERT-like model from Microsoft. In the beginning of the year, they overcome human baselines on superglue benchmark, and that's cool. And Microsoft announced that the DeBerta model will be available sometime in Microsoft Turing family of models. It is called Turing NLR v4. But right now, there are very few information on this model, and it's not available for public use, but we'll soon see it. And on
to say more correctly, there is very few information, and even this information is covered by NDAs.
Yeah. And on the next slide, here's a brief visualization of different tasks that can be implemented with BERT-like models. So you can do different classifications for sentence classifications, like sentiment analysis or spam detection or any other task that you can describe in terms of classification, or multiple sentences classification, or sometimes you can use this model for question answering tasks, or you can use these type of models for sentence tagging tasks when you need to map every token to a particular class, like object, subject, or part of speech, and so on and so on. And another type of models, another well-known model is T5 model. Again, it's less well-known than GPT or BERT, but it's still an interesting model from Google. And for T5 family of models, T5 is a large transformer that is performs full sequence-to-sequence task. What does it mean? It consumes a sentence or some text on its input, and it generates a text on the output. And in this way, you can formulate many NLP and not even NLP tasks in this way. And the original T5 model was pre-trained on a BERT-like style tasks, but it had to recover not single tokens, but spans of tokens. And then the typical way to use T5 model is pictured on the next slide. You take the pre-trained T5 model, and then again you fine-tune T5 model on your particular data set. So you have to train on your own hardware or in the cloud. So it limits its applicability. You still have some clever AI people, you have some infrastructure, but for cases when you need custom models, you can fine-tune T5. And there is MT5, the multilingual version of T5, and that's a general direction of transformer models in the last year. Many models become multilingual. That's an important point. GPT-3 is still English model. It knows a bit of other languages, but it's still mostly English-based model. I hope we'll see sometime multilingual GPT models, and that will be cool. So here I will stop and pass the stage to Konstantin back. You're muted.
Yeah, Konstantin, you're muted.
So to quickly summarize, basically you have a model which is trained on all data in the world, all texts in the world. Much like Google searched all websites in the world, and you can type your query, and if you're good at query typing and lucky, then you get what you need. With GPT, you can describe what you need, and maybe it will generate what you need. But since the interface to this model is more or less natural text, you have to explain what you need in natural text. So if you think that it's very similar how you explain what you need to a human colleague, you're not very far from the truth. That's pretty much how it works. So, you know, if you work with people more and more, you start to become better at explaining what do you need, and suddenly at some moment they start doing what you ask them for. So let's look through a number of practical applications which we see. You know, there's a list of these NLP tasks, but let's look at practical tasks which you may see in the current language industry, which are adjacent or somehow related to translation, or typically done by humans. So we'll go through finding titles for descriptions, simplifying texts to be more understandable, then writing descriptions based on certain keywords, then generating scripts, then paraphrasing, source quality improvement, so that, for example, user content becomes more understandable by machine translation and chatbots. And finally, we'll look how it's possible to use this type of models to generate image captions to make websites and catalogs accessible. So, okay, we have this talk, and I mean, and full transparency, title and description of this Gala webinars were written by humans. We decided not to risk here. So we were arguing a little bit about the title. So one idea was to put what you see in the Gala website, who's link whom to where, which is more understandable, probably. And we had this crazy idea of having their black swans as stochastic parrots, and we decided to combine it somehow. But what if we wrote the description, but we want to see what options we have, how to call this talk, how to call this webinar. So let's see what GPT may provide. And again, full disclosure, there are no cherry picking, meaning that there is a number of variants generated by GPT consequently, and there are no editing. So just basically first several attempts. So transformer models in context of content creation. The content creator's new nemesis, a text transformer in your pocket. Generative text transformers, the future of content creation. Text transformers, artificial intelligence for content creation. What will happen to content creation? Deep learning models are changing the rules. And text transformers for content creation, the good, bad, and ugly. So it's up to you to decide how good those titles are. I'd say they're on average better than average titles you see on conferences. Then let's look at text simplification. So again, let's take this description, which we have with lots of interesting abbreviations, GPT-3, T5, text transformers, AI, and so on. And let's ask the model to explain it for a second grader. Okay, maybe if we took a higher grade, we would have more lengthy explanation. But I would say that's, again, it's pretty close to what we're talking about. So next application is writing description based on keywords. I think you may have seen products in some online shops, where instead of good description, you just see a set of keywords. So let's ask a model to make sense of this set of keywords and explain us what this product really is. This is a half-face mask that covers the mouth and the lower part of the face. It's made of cotton and is black in color. It has cartoonish design of a mouth with teeth. So there are no additional information, only keywords, and the rest was reconstructed by the model. So basically, it's some sort of copywriting. Then there's a number of cases where you may want to build lots of similar scripts. So one of those cases is, for example, interactive media. When it may be a game, and you may write one dialogue, and depending on who player is and what NPC they interact, you may want to modify this dialogue slightly. Another case, you may be training some model, for example, named entity extraction model or anything like that. And you need lots and lots of different options for different metadata. And in both cases, you have decent copywriters and subject matter experts. And like with translation, it's a matter of what they're focusing on. Are they focusing on producing sort of general small talk, or they're focusing on just reviewing the scripts and making sure that those scripts are diverse enough and cover properly the subject matter domain, and so on. So here's an example. One script generated to describe specific at-a-counter situation when a person checks in for an aircraft flying to New York with 2 bags of luggage. And then it can now just change metadata and generate other dialogues. So no luggage, and you see how this part where they describe what's happening with luggage, and weight luggage, change just, okay, I need just a boarding pass, and here we go. And maybe it's not an aircraft, maybe it's a bus. And Mary's traveling to Sacramento, and suddenly model figures out that, okay, if it's a bus, then maybe it's Greyhound, because it's in the United States. And it also uses a little bit different terminology from what people at airports use. So next task is paraphrasing, which again may be very useful if you, for example, you want to build a chatbot, and you have you came up with a few utterances which describe your intent, but you want to generate more, and you want to see all different options. So you need someone who read all English text in the world and can tell you how what are the different ways in the English language to describe the same thing. GPT is a perfect candidate for that, and you see it just changes different. A little bit different parts of the sentence, preserving the same meaning and metadata. So then another task is source quality improvement. And one case you may have when you have a text with lots of slang and abbreviations and you want to machine translate it. So that's the most bizarre text like that I found in the internet. If you run translated to Spanish through some decent machine translation engine, you get pretty much the same, but probably it will, it's still in English, sort of, if we dare to call it English. But you may ask the model
Oops, I think we lost Konstantin. Maybe Grigory, would you like to take over while Konstantin's connection comes back?
Yeah, I'll try.
Okay. Apologies, everyone. This is live, so.
But I cannot share my screen.
Oh, okay. I think we're stuck, basically. Okay.
Mm-hmm.
Do you want to try again sharing your screen, maybe?
Yeah.
Okay. Yes. Excellent.
Yes, but you can ask the model to improve this text, to translate it actually into English, and you see this slang is being translated into nice looking English text, and then you can use the ordinary machine translation to produce a meaningful Spanish translation. So that's useful improvement for such kind of communications where you have a lot of slang possibly. So that's a good example of using GPT-3 for this type of kind of English to English translation. And you actually can use your GPT model for source quality improvement. For example, you need to train your chatbot for some type of conversations, and users are usually not perfect in English or in any other languages, and they tend to use slang, they tend to have typos and some mistakes in spelling words. So you can have this type of text, and probably your chatbot that's been trained on normal English can deal with it. But you can ask GPT model for improvement, for rewriting this text, and it looks pretty good. So with this rewritten passage, your chatbot can easily deal with. So that's again another example of English to English translation of text improvement for later processing in a pipeline by different modules. And another example, not directly related to GPT-3, but where is the future? The future is in multimodal models. By multimodality, I mean the models that work with different modalities like images, text, sound, and maybe some other modalities. And right now, models that mix text and image are emerging. Maybe you heard about Clip or Delhi by OpenAI, and there are other models. And for example, you can ask a multimodal model to describe an image. So you provide it with a picture or photo, and the model generates a text that describes this image. Again, that can be useful in many ways. You can improve accessibility for people with problems with vision, or you can augment your database of images and photos to, for example, to search through it, and you can combine these bricks in the pipeline into any meaningful way. So that's a good option we'll see in future. And again, you can later expand this text into something other.
Hello. Hello. Sorry, my internet was down, so I'm dialing in. Grigory, can you show the slides?
Yeah, I'm showing. I'm on the accessibility slide, and I describe the case with image captioning. And
okay,
here are some remarks slide, so you can continue from it.
Good. Yeah, so as you see on the slide with image captioning, there is a slight mistake because the girl is not reading the book. It actually opens the box. But that's something which may require human editing on one hand. On another hand, that's not a serious mistake. So it conveys the main message here. So what we can say the remarks is that first, the generated output of such models, it must be reviewed and edited by humans because it may contain all sorts of biases. And in some cases, the model it may generate something really weird, which you don't really want to see anywhere. And also because the content can be published on the internet, and when, OpenAI will update the model next time, it may take it as a training data. So, and if there's any of these wrong things in the content, the model will be trained on that, it will assume it's something, this bias will reinforce itself. So this is a requirement by OpenAI as of today to use this content only under strict human supervision. And all commercial and production applications of this technology, they must be approved by the safety board of the OpenAI, which we went through this approval some time ago successfully, and that's not a very easy task. You have to explain a lot. And much like with machine translation, effective post-editing, humans working alongside machines requires retraining of humans, requires different workflows, requires different tools. So just dropping in GPT or any other transformer in your text editor may not work, may not lead to the type of ROI which you expect, much like with machine translation. So probably as we may summarize, you see that these transformers are capable of offering content of quite decent quality. And Isabella mentioned Guardian article. I've seen recently another case when a person who was just editing GPT blog posts became a top contributor at Hacker News, which is one of the very top-rated news resources in IT world. And transformers, they may deviate from the task because maybe you described it ambiguously. Maybe they just was in this mood today. And that's just much like with humans. And much like with humans, they may, even if they, you provided all the context and the subject domain is clear, they may expose biases or lack of expertise. Nevertheless, we see that with this part of content creation chain covered by quite decent models, we should expect post-editing in all places of content creation. So if you're a copywriter, this is no longer a safe haven where you can sit and work and expect to work the way you work for the next many years. It's already over. You have to learn. You have to learn how to use those new tools. And if you're a business, you need to start thinking about what could be proper tools for humans working alongside machines in content creation. What are the proper workflows and what are the proper business models? Because this is pretty much uncharted territory. And again, like with translation, it feels that companies who will figure out that first, they will actually become market leaders. Yep, I think that's what we have for today. Sorry for those internet issues.
Thank you, Grigory, and thank you, Konstantin. There's a little echo. Okay. So let me see, because there are a couple of questions from the audience. First of all, you guys mentioned, I think, Grigory, it was you who mentioned prompt engineering. One of the questions was, how long does it take to complete a prompt cycle? Maybe you could tell us a little bit more about prompt engineering, because the general idea is, oh, if I have a GPT-3, I can just throw a sentence in and I'll get what I want. But you clearly stated that it's not the case. You need to fine tune your prompts as well. Maybe you could tell us a little bit about it, and how many prompts are necessary, for example, to train a model.
That's a tricky question. Sometimes when you're lucky, you can get good results from the first run or second run, or maybe from a small number of runs. But in many cases, you have to try a lot, and tens of different prompts is, I think it's normal. Maybe Konstantin can explain his own experience with some of the examples, but typically I think good prompt is not an easy thing.
So yes, it gets especially tricky when you need to produce a long form content and keep it consistent, because you have this very strict limit on both prompt and output, and you have to split generate this large content in pieces, and then you have to make those pieces consistent, right? And that's, I said, here we go to a field of our know-how, because we've developed quite decent approach to that. So all I can say is that it's possible. It's not easy.
Mm-hmm. Okay, thank you. So another question is about user guide, user support. I think you guys already touched a little bit in your presentation, but Dimitri has a question. For example, could such models fine-tuned on a user guide, could they provide user support? For example, replace a support specialist in answering user questions, or even provide more intelligent support. For example, if a pre-trained model is fine-tuned with past dialogues, for example, between users and support specialists. Who wants to take this, Grigory or Konstantin?
Well, as we explained, having a human reviewing the results is absolutely necessary for outbound content here. So it can simplify the job of a support specialist a lot. Probably with some fine-tuning, in many cases even without fine-tuning, to help generate drafts of answers. But given our experience, fully replacing, and that's a good thing, you can use it to fully replace human, because it's sort of has its own mind. It's maybe frivolous in its own non-human way. Mm-hmm. So you really need supervision here.
Okay. And then in the green room, before we started this webinar, we were talking about the costs. And here is a question for you guys. It's in two parts. So are there already pre-trained transformers on the market that can draft product documentations like user manuals, for example? And if so, how can I acquire a transformer and train it? And how much is it going to cost, actually?
You are unmuted.
Well, I think here, training costs to train it. So there are pre-trained transformers like GPT, and I think here's Grigory, Micro 95, I think coming soon after. We are expected to go general availability at some point soon, right?
Grigory, you're muted.
You could probably try to use open source GPT and retrain it or fine tune it for yourself, but it's hard. The full tasks of creating documentation and user manuals, I think it still be human tasks, and these transformers can make this process easier, but I think in short term they will not replace, because typical user manuals are much longer than transformers are typically work with, and it's hard to generate consistent documentation of in large amounts here with any transformer.
Well, that's from one side. That in order to generate user documentation the way humans write it, it may be complicated. On another hand, if you will think, would your users like to have shorter documentation which addresses their questions more directly? Probably they will, and that's something you can do. And if your company has public materials, lots of them in the internet, there is a good chance that actually models like GPT has a decent knowledge of what you do and of your products. For example, one of the tasks we use it internally for to generate drafts of press releases. And I tell you, GPT already knows a good deal of chunk about intent. So the cost, and when you use this model in runtime, cost is a little bit tricky, because again, if you look at the per megabyte cost, it's about the same as machine translation. But since this volume includes prompts, and sometimes you need lots of those prompts to generate one text, and you have multiple passes, it may get quite expensive. It will be still significantly cheaper than doing it from scratch with good human copywriter. But it will take finding a right editors who will be work efficiently with this type of content.
Okay, well, thank you both, guys. It's been very interesting and rather exciting technically speaking. You've been great. And I would like to thank you also, all our attendees, for joining us. We have two bits of news before I close the webinar. The first of all is that on May 25th, we have our very first Global Talent Lock Mixer. It's a virtual event specifically for localization program students, recent graduates, and localization professionals. And you will be able to meet and connect with the counterparts around the globe to learn more about student-led initiatives and how to enter the localization industry. Another bit of news is that we have opened our call for proposals for our September conference. So please visit our website for more information. Again, Grigory and Konstantin, thank you so much. It's been very, very interesting. And we hope you'll come back to tell us more about this rather new and challenging technology, and maybe bring some more interesting examples.
Thank you.
Yeah, thank you very much.
Thank you so much.
And if you have any questions, send them by email.
Absolutely. And by the way, to all attendees, Grigory and Konstantin will share the slide deck. So when you go to the Gala website, you can watch the recording and you can download the slide deck for more information. Thank you all, and yes, a good day or a good evening, depending on where you are. And I hope to see you soon at another Gala webinar. Goodbye.
Goodbye.